DraftScience video. Don't exactly know where this one's going to go. Kind of some overview stuff, I suppose, but just the argument in defense of the fact that what I'm proposing is a radical departure from conventional physics, and whether or not it's will radically change what physics does in the future. I mean, it's not going to change what we've already learned about the facts of what the effects are. This is more about a radical change in what we define as the causes, and that may or may not create a benefit to the progress of science. It's not really the issue. The issue is what's the truth. But it is radical. I mean, it's a complete infrastructure change. And when people like Hofladay just play this game like that doesn't mean something, that's really irritating. And that's all I'm saying. That's really irritating. Now, you can't understand why that's irritating. That to me is sort of amazing. All right. So anyway, I couldn't even watch the video. You play 30 seconds of it, and you just say, "That's such an outrageous pile of crap," and you're just saying, "How can I continue watching when you're going to say things that are such outrageous piles of crap?" And so the only thing I could analogize it to is it's sort of like arguing with or having a conversation with, like for fun or for any purpose whatsoever. Most people who believe in evolution really won't engage with some fanatic Christian because they know they're just going to sit there and force them to explain every single absence in the record. Why there's no missing links, and then you have to explain, well, look, it's punctuated equilibrium. The amount of people who were changing was very small, and so there's no fossils of those very small populations, and blah blah blah. So there is explanation, but you have to go into a lot of detail to explain these stupid and silly objections. And then you point out something like hip bones in a porpoise or something. The bones in a fin. Show some pictures of a gestating killer whale and a gestating human, and the gross similarities in their development, something like that, and they just go, man, so that doesn't mean anything. So you know what the conversation is going to be like, and it's just going to be a waste of time. So I don't mind the detail. Like I said, I like getting into the grit, imagining structure, because that's all we can do. We'll never get hard evidence of it. So it's a real detective kind of story. You only have the knife, in the bathroom, blah, 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 and that's all you have. And you have to generate an understanding of what all the causes were that led to this knife being in there. That kind of thing. So I don't have anything against that. I just have something against it when the asshole doing it has no intention of accepting anything. It's just a waste of my fucking time, because this isn't what he's hanging on. What he's hanging on is his delusion, that his God model makes any sense whatsoever. And Hofladay just demonstrated that in this video. I mean, alright, so he calls this some fair analysis of DraftScience. And, so yes, I'm expecting something fair. And then he starts telling me how this God theory of current science, current physics, has explained this detail. That they have all these great drawings and great images and you can cognize it all. It all fits right in your brain so easily. Bent space, yeah, it just fits right in there so easily. In 3 dimensions especially. Yeah, that just totally makes sense. So I can draw a picture of the standard wave model. I mean, should I really have to draw it just to? I mean, you can just use simple, examples and just point out from those simple examples. You gotta go down the right places here. Well, I already fucked it up. Do this one first, and then do the other wave, idiot. Okay, well that makes sense. And then put the little lines through it, and then they'll understand this one's going this way, and this wave's going this way, and this wave's going this way, This wave's going this way. Anyway, so this wave model of a photon, it has this electric component going this way, and there's a magnetic component going in this dimension, or something like that. This very idea is just totally idiotic in the sense that we know from water waves. Like, let's say there's a medium here, and it's displacing the medium. Well, that would mean that photons would be creating displacements in the wrong direction. These fields would be the wave. You know, when you see a water wave, you're seeing the actual displacement because water doesn't compress. So you're seeing the actual expansion. You're seeing where there's too much water. That's what the wave is. It's a representation of the water's definitely on here, and it's off here, and it's on here, in terms of this excess amount of water. And so they give you a diagram that pretty much can't work because, you know, the displacement's in the wrong direction. The displacement is saying I'm vibrating the atmosphere, you know, that kind of thing. The wave is obviously doing that visually. You can see it. That's its effect. We know photons don't do that. We know they don't radiate anything called magnetism or electricity perpendicularly. They don't have any effect. So it's not a model. It's not an explanation of anything. It's not a diagram that means anything. And, you know, he's talking like, well, they've done their job because they did that. And then he's expecting from me an X-ray of an electron. He wants to see its X-ray. Its bone structure. I can't just talk about what it does, its properties. And at least I'm not drawing a completely ludicrous diagram that doesn't in any way demonstrate either the direction or the intensity of the movement of the force. Because obviously waves don't really work as a diagram for a photon because it doesn't spread. And the force is directed at one tiny point in space that moves in a straight line, by the way. Well, anyway, so like I say, some fair analysis, and he spends the first 4 minutes of the video. So I'll go back and I'll play some of it. But I mean, it's just, you know, defending the current model as he's perfectly satisfied that they've done their detailed job, that they've given us visualizable mechanical structure that's totally understandable, and yet it's layered in Heisenberg, Huygens, virtual particles, annihilations that aren't annihilations, creations that aren't really creations, antiparticles that aren't really particles, they're just empty spaces in fields, field theories that describe every single particle as having its own field, its field of what, its field of whatever, the whatever force, the whatever field. How can you, how can you say you're being fair when you say all that mush, that undescribed, ambiguous description of effect, has anything to do with giving you a single piece of cause? And then you badger me after I've given you a ton of cause for, like I said, the X-ray of the cause. I mean, bullshit, if that's fair. Just bullshit.
Biased and not asking this question of Einstein. Yes, I am not asking of Einstein, but it's asked for physics and they have an answer. They have an answer for structure.
So, he says that. They don't have any answer. Every single discipline in physics has no answer. I can't cognize. I don't have a mental image of a single thing they're talking about. They can't even, besides the energy levels of electrons and atoms, even the whole idea of how they're spinning or what dimension they're in, all of that has become ambiguous. They're in some vague field of influence. They're not even in a place anymore. I mean, what are you talking about? What about it is at all mechanically sound? I mean, that's just rubbish. Again, Copenhagen, many worlds. They have a million theories for every single thing. String theory, come on. What do you mean there's some sort of hard, grokkable pieces to this thing? There's no pieces. None. None of it matches. I mean, again, they're never gonna, they can't blend this quantized thing into this wave thing. So they broke the whole game when they did that. You can't do quantum wave.
You know, based on symmetries and quarks and...
Yeah, there we go. Yes, and the quarks antiparticles and the quark field and the Higgs boson field. Oh, come on. And so all I have to do is put so many pieces into it that you just lose all will to live. So if I make enough convoluted pieces with convoluted silly names and convoluted silly purposes and functions, I'll just lose you in the detail, and that way my detail doesn't have to make any sense at all. Again, they can't even make rational mathematics for the two-slit experiment, and yet you say they've got it all sewn up on the nuclear level. Bullshit. Sorry, I'll move ahead a little. But then he defends the opposite argument.
It seems to me that you've done that now, and it's fine. I won't bring it up again.
Right. So I didn't say don't bring it up again. I said, hey, you're being unfair to expect one man who's done this for a couple of years. Okay, they've had 100 years to fiddle with their friggin' silly Heisenberg bullshit theory. They've had 100 years to come up with rationalizations and excuses for why, oh, it sort of works the not working way. You know, we have catch-22 and catch-22 and catch-22 and catch-22. You know, the headlight effect, some other damn effect. Yes, that'll fix it now. Later it'll get us in trouble, but it fixes this scenario. They've had 100 years to do that bullshit. And I don't even want to do that bullshit, frankly. I'm not interested in bullshitting. So, I mean, where was I? Yes, so again, I'm just saying for my purposes, I first have to get people to say, hey, conceptually I get this. Okay, you can just get rid of all this magic bullshit, virtual bullshit, fieldy whatever bullshit, and replace it with something that unifies gravity and magnetism, and will explain to you how electricity really isn't a force. So you don't have to worry about that. There's no electric force. You know, there's just electrons moving, which is a consequence of the gravity magnet thing. It's a consequence of the pressure being created by the internal magnetism.
The statement of your theory, the most general statement of your theory, is simply, hey, look, guys, you don't need magical fields to describe forces.
Right, and this is a trivial thing. So he's basically saying that's all it does. It doesn't do anything important. Yeah, right, and it unifies. So again, let's just say, let's emphasize again, it makes a clear connection, clear, obvious, like, whoa, right in your face connection between gravity and magnetism. Makes them not even brother, they're fucking Siamese twins almost. It's so clear.
It can be described by particle interactions quite easily. And I come to the understanding, I think, because for a long time I was critical of your polarization theory and thinking that it yielded a magnetism, let's say, and a gravity that was just in simple proportion, that one is half of the other. But I realised that that's not the case. It's dependent. The discrepancy in the values is just merely dependent on the proportion of the types of polarization in the sea of quanta.
Yes. I'll say yes. Clearly polarization is the thing changing. And clearly that's what a magnet's doing. But it's the same force. It's not extra force. So that always has to be emphasized. So, yes, when it's polarized, it's more effective. When it's not polarized, it's still a force. That's the catch. I didn't watch this part, so I guess we'll speed this up a little. See where he goes from here. See what his big complaint is. I thought I would just because I was thinking of some of this minutia, the detail stuff. And it's this question of what exactly an electron is. And the first thing I wanted to emphasize is that what's the difference between matter and the field stuff is this whole point of I just can't stand it. You know, this getting old thing sucks. These words they just disappear. You're just like, where the fuck did that word go? So I will have to look on my piece of paper here and hope it's there. Velocity imbalance. Virtual photon length. No. Come on, it's that stupid. My brain keeps saying singularity, and I keep saying no. That's the wrong word, you dumb fuck. Superposition. There we go. Okay. All right. This idea of superposition, the original idea, which is the forces don't interact. The forces just don't. You can't make the magnetism affect the magnetism field. It has to affect another magnet, and something that can be converted into a magnet. That's all of the magnetic things, like a piece of steel or something, is not intrinsically magnetic, but it can become magnetic really quickly. And so that's why it reacts to a magnet, is because it's now a magnet. So now the field can interact with it. It can detect the polarization. It's just so obvious. Anyway, so the real point is the real strong point to make is that, okay, so you have these two elements, and to me this makes a lot of sense. You have the matter bits and you have the force bits. So the force is in this form of magnetism and gravity, these little quanta, and then when you put them at a frequency, they're the electromagnetic spectrum, which is all the photons. So all the photons are basically just those little bits that cause gravity and magnetism, and in the case of the photon, they have a frequency, and so you can detect them based on their frequency. Electrons can sense them that way, appreciate them on that level, let's say it that way. They'll behave differently based on the frequency they are hit with. But anyway, the matter bit. So why? So the point is that there's this simple reaction, which is the right turn. So this is what makes the universe happen. Is that something goes in. Say this is a say this was. Well, I mean, I can do the red and black thing, but it's for this purpose. It doesn't really matter. But something goes in. Let's say that's red, and instead of reflecting a red back out, it reflects actually a black back out. We don't count that, but that's what really happened. And this I probably should actually draw it that way. So it reflects. Say this is black, and so I'll just make this so it reflects actually a red. All right, and what it ends up, in the sense that something leaves, and so the black ends up going out this way, so it leaves black. Okay, so the reflection has essentially been replaced in the sense that it exchanged a red for a black in terms of the actual reflection taking place. And the consequence of that is also you absorbed a black going this way. So this thing moved forward. Now, what the point is that it only moved forward one quanta. So it's sort of the argument that so the real point is that you have the matter bits. Now I'll confuse things by using two colors for different purposes, and the force bits. So that's all the universe is matter bits and force bits. And all we're talking about is when force bits hit, they can either reflect purely. Okay, the little force bit goes out, and this thing moves one little bit of movement. And that will depend on how much mass we give these matter bits, the electrons and protons. Now, they could be almost massless, in the sense that they're just things that can sense the force. So the argument is the force bits can't hit each other. So let's say there's no interaction between the force bits. Force bit against force bit, it just doesn't mean anything. Nothing happens. There's no interaction. And so the key to the universe is the fact that there is this interaction, and the fact that you can have two bits that end up bouncing these little bits back and forth between them. And that can get, as they get closer, that pressure, they're getting hit more and more and more. That's the effect that is the universe. That's all the stuff we see is happening stuff, is because the matter bits interact with the force. And that's it. And they interact in this simple way. Either the thing bounces off, as in this diagram, or it goes out perpendicularly. Now whether it goes out perpendicularly, the reflection is essentially just moved to this location, or it bounces back regular. No matter which way it reflects, it always gets this little push this way. So it moves one, so you could say it moves one, so the interaction, you could describe the interaction with matter two ways. And I'm not sure which way is right yet. That when the force bit hits, it consumes one quanta of time, because it just basically has to do this U-turn thing, and then send the bit out. So that one little bit of time is the thing that moves this one space, if you get my drift. But see, and the fact that it's sent it back is sort of important, because you can sort of think about an electron getting pushed out of, like, say, an explosion of some kind, and it's leaving. Well, why is it leaving? Well, as the force bits are hitting it, pushing it away, right, they're reflecting off of that electron and going back to their source, and they're reflecting off the source, and they go back to the electron. And this is all happening at the speed of light, so you can imagine when the electron's really close, those are a lot of impacts. And there's still impacts as it goes further and further away, because there's still a lot of force between them. So it just keeps getting pushed. But eventually, the length of the distance is so great that the number of impacts is so little that the electron starts moving really, really slow, because nothing's hitting it very often. So in theory, it could be that simple, that the electron and the proton are just little hard bits that the force can hit. The force can't hit the force, but the force can hit these bits. And that means that the bits are just channelers for the force. So the bit could just sit here, and it could have force hitting it this way, and then force hitting it this way, and so it goes this way, and then it goes that way, and then it goes this way. So it's constantly being it's just allowing the force to interact with itself. So this force gets to interact with this force because there's a medium here, this little bit, that allows the two forces to communicate. And if there's another bit here, and there's another bit, say, over here, it'll be kind of obvious that, well, this closeness means that this is going to have a lot more impacts on this side than impacts that'll be on this side. And so these things are going to definitely move apart, and this thing's going to tend to move closer, and the two will end up evening out and equaling out. And that's what the universe is doing. But it's just this right turn thing. If it wasn't for the right turn thing, there wouldn't be a universe. Nothing complicated could happen. Because once you allow the right turns, you can just imagine the right turn ends up going into the proton right turns it into another electron. It allows electrons in completely different locations to communicate, because there's a bunch of right turns that end up getting force from here to there through all these right turns. And as I've pointed out before, 4 right turns and you've got a circle, essentially. Well, anyway, so I don't know if that's a clarification or not. Again, it's so hard because you know the people listening have different levels of understanding, really different levels, and so you don't know where you lost somebody. And so that's why I appreciate people saying, okay, this is where what you're saying doesn't make sense. That would be really swell. So if instead of spending 8 minutes defending a concept of fairness that I think is just insane, i.e. saying that physics was fine the way it is, I mean, I wouldn't have gone looking for this if physics was fine the way it was. If physics had even just one good description of one element of physics, if they had even just one piece of it rock solid, I might have had enough. Well, they sort of know what they're talking about, to say fuck it. Why go try to outdo these big brainiacs? Okay, but the fact that everything doesn't make any cognitive sense to me. Every single thing they say is exactly opposite talk to me. It sounds like an insane God theory. Every single thing they talk, Heisenberg, I mean, this whole idea that the photon doesn't know where it is, that it has no location, and especially when you're going to draw that conclusion based on its interaction with electrons, the thing that you know to be unreliable, crazy. I mean, it's a little crazy machine, electrons. Why would you blame the photon? When you have two, like I say, it's like their diagnosis of the crime is completely backwards. It's like they have this little old lady living in Pasadena who's done exactly the same routine her whole fucking life, and she pets flowers even. She's so nice and kind. She pets flowers. You know, Daisy, she pets them. You know, and then you got this psycho killer living next door, and you got a murder weapon, and you're wasting your time interrogating the old lady. I mean, that's that bad. I mean, they're giving photons 5,000 million crazy properties when they know the electrons are a lunatic. It just doesn't make any sense. For you to sit there and tell me you're being fair, to interrogate me on details that the entire field of physics hasn't come up with 1% of. Not 1% of what they teach has any hard model of cause. Not just 1%. And you'll sit there and say this bullshit that you're being fair. Come on. Because you're asking me for an x-ray of the fucking electron. Come on. Now be a fair. How can you call that fair? I mean, it's just an insane definition of fair. And then I'm saying, well, why am I talking to an insane person? Why bother? He's a religious kook. He's a devotee of the conventional theorem. I've pointed out how a ton of it is just built on assumptions. Not evidence, just assumptions. And he just ignores that and says, no, they've got some really hard, good quality stuff here. No, they don't. They have good quality effect knowledge. Because yes, we've all been electrocuted, we've all stepped in mud puddles, we've all slipped on banana peel. So yes, they have lots of effect. But they have shit for cause.
So, you know, I ask you about the structure. No comment.
Yeah, there's not no comment. Like I said, I gave you a ton of structure. A ton of it. But the really important feature is, this is what matter does. Electrons and protons have this simple function. They either reflect back where the thing came from, or they reflect 90 degrees. You know, on either plane, either dimension of the 90 degrees, up or sideways. One of those dimensions is where they excrete the reflection. That's it. I mean, I've cut it down to almost nothing. And so yes, what the hardware is that allows that to happen, okay, that's a little bit complicated. And the momentum argument, again, I'm saying the momentum argument is really just, it moves a quanta. It moves a quanta with each impact. It doesn't need to have a storage capacity. But I think it does. So there's no point in me saying that that model will still also work. Because I think the real model is that it does contain some storage.
And, like I said, that's your central theory, is, hey guys, look, and I give you a mechanism and show that all forces can be thought of this way. It's limited insofar as it doesn't give insight to structure.
It does. It gives a huge amount of insight into structure. So again, you're just denying it's much more insight than you ever get from regular physics. and it's completely mechanical. I mean, certainly the ins and the outs are more obvious. There's no virtual, there's no field, there's no wave. I mean, shit.
But that's fine. It's an interesting thought, and
it's more than an interesting thought. The point is, it's a unification theory. It simplifies and unifies. I mean, it's huge. It's not a little change. It's radical, complete fucking paradigm shift. And you're sitting there just minimizing. Oh, no, well, it just takes care of one little tiny, 1/millionth of physics is changed by this idea. No. No.
It has a concrete handle on it that is more intuitively bearable in philosophical terms of maintaining.
Well, again, I'm just sick of this. I already went through this video talking about philosophical terms. I guess we're just going to have to say that we have a fundamental incompatibility in how we use language and how we think. This has nothing to do with fucking philosophy. It has to do with facts and evidence. And getting it right or getting it wrong. Accurate descriptions of reality. That's not philosophy or science. That's just the truth, fucker. Okay? It's sci-philosophy or philosophy or whatever you want to call it. But the fucking point is, as an accurate description of the fucking thing. Alright, and so playing this game about what is a philosophy and what is a science is just fucking word rubbish. You either accurately describe something or you inaccurately describe it. Period. I'm doing the accurate description thing. That's my intent. Fuck. I don't care, this philosophy talk. Bullshit. This has nothing to do with philosophy.
A reality where, like, I think Bohr said, since quantum mechanics, hitherto anything that you consider real can no longer, in the thoroughgoing sense, be real.
Yeah, well, whatever. Again, this whole point of even being able to say what's real doesn't matter. I mean, the point is I mean, the threat is what Bohr was really saying was, we can make up any kind of crap we want to now. Free will. We can have double free will or triple free will or free will to the 14th power. You know. I mean, it was just basically saying it's all mush. There's no coherency. Yeah. It's all Heisenberg. If you have Heisenberg in one place, it's going to spread everywhere. You can't get away with that. Uncaused magical probability cause.
Quantum mechanics, something like that. So in the philosophical leap to say there is reality, means something.
Yes. Well, I'm just saying it's not a philosophical leap. It's not a question of philosophy. The whole point of even having a conversation about anything is to describe the truth. If you people are in some other, if you're trying to do something else besides describe the fucking truth, then I shouldn't be fucking talking to you. So argue a truth to me. Argue facts to me. Don't argue philosophy.
Then there's a lot to be said for the argument to henceforth take your point of view and to the problems of structure.
Yeah, well, the point is what is a more defendable theory? If you had to defend it, if you had to be a lawyer for it, okay, what I'm saying is if you look at these two starting models, the push versus the pull, okay, I don't think you want to be the lawyer for pull. Because, yeah, push is a lot easier to defend as a fucking concept to start with. That's even the starting point. And then you're just saying, what do you want to be the lawyer for? A universe made of bit forces and bit matter, or a universe made out of wavy ether perturbation in the who knows-y what-y, and the bent, this and that-y, or that rock-solid theory. Which one do you want to be the lawyer for? Which one do you want to be your client? I'm saying I'm winning if any rational person had to put their real money on this, they had to really invest some piece of their soul, I'm saying they're going to know which one's going to pay off. And it's almost like the inverse of the religious argument, right? Because that's the God of the gap, the foxhole convert. Well, what do I have to lose? They have a word for that when you just accept it because, hey, one theory offers me some hope of candy, and one theory offers me no hope of punishment or candy. I might as well invest in the one that's some hope of it. Is that all this is? Is you're just investing, people just going to invest in, well, popularity? I'm just saying if it was their real feet, if I could really make it so their feet get cut off if they choose badly. If I could make this a real question, okay, your feet are going to be cut off if you choose, or your dick, if you choose badly. So here's your choice. Universe based on push, universe based on pull. Universe based on 4 zillion magical woo-woo fields, or universe based on little bits moving little bits of space and little bits of time. That also fits the evidence of all the forces move at the speed of light. It's convenient that you don't even, this isn't even a hard one because it's just so obvious. Shit. I'm saying I would win if there was some kind of way I could make this real for these cunts that are defending this fucking religion.
Sure. Inmendham has the reply. Well, it could be many things. I'm not going to say what it is, but if you think of the velocity's kind of maintained, and you have it doesn't quite work out because it does have problems.
No, you're just describing something. You're saying, look, it's a round wheel. I don't know. Is it rubber? Is the wheel wood? Is the wheel made of tungsten? I don't know. But it's a round wheel. I mean, it really doesn't need explanation in the sense that this is... I mean, yes, it could be fun to try to figure it out. But I'm just saying, for now, that's a waste of my time. Because I got to get people to accept the round wheel. Fuck.
Certain aspects of it, you can see intuitively plausible the notion of schools of fish giving something, but it needs more, which I guess Inmendham...
Yeah. Well, what I'm saying is I don't think it would need more if people could, like I said, if I could force them to really invest in it. Let's just put the two theories next to each other and just say, yes, okay, well, here's the dancing analogy. I'm saying that, electrons and protons and all of matter has a metabolism. It's a function. There's forces moving between them. It's swirling about inside of them. It has a timing cycle. And if you move that thing, it's like asking a dancer to move left or right. He can't dance as fast. And that's why less radioactive particles pop out of some atom, is because when it's moving, is because it can't do its processing quite as fast because it has to waste time going in another direction. It has to add some more velocity. It has to add a function. It has to multitask. And the rule of multitasking is it has to compromise the other tasks. They can't be done as fast when you add a new task. Or the contrary theory, which is time is bent and everybody gets to bend a little bit of it. And if you're in a frame with other things, you get to bend a lot of it. Maybe. Kind of. Whatever. Time is some sort of dimension that can be wobbled and bent. That's the alternative explanation. I'm just saying, if I can put their feet on the line, they're not going to invest in that silly mush when they have a perfectly rational choice.
Admits because he has to talk about lock-in and other things, but they're elements of an attempt, and the suggestion...
It's like the God theory, right? If you could actually guarantee to somebody, here's your choice. God did it or evolution. And if you're wrong, you go to a real hell. You really go somewhere and get tortured. I'm just saying most people, when they know their choice is, oh, what's more rational? They're going to choose evolution.
That there are better avenues of thinking and reasoning about that structure than the invocation of pure math, which and then
there's no pure math. So that even calling the mathematics they do in physics anything like pure is almost disgusting when it has 10 million little catches in it for all kinds of bullshit. It has non-real numbers and, you know, abstract matrices and, you know, come on. To call that anything, call that pure is just rubbish when all it's intended to do is make approximations, round off corners, cut off pieces that don't matter somehow, you know. I mean, to call that something that's doing something pure, I mean, it's fucking chopping fishes up or something. I mean, it's wasting a ton in the process. It's nothing pure about it. It's certainly nothing anywhere close to something as clean as 2 + 2 = 4. Not even close.
Labeling the abstract mathematical structure, I mean, quite literally in the case of what's his face with his mathematical hypothesis, that the abstract structure is reality. It just makes no philosophical sense or has no philosophical grounding at all.
Yes, because two-ness is a ness. It can't be something that is, in the sense of what the things are. They can't be two. They have a ness. They have the property of two-ness. It's something like having long hair. You first have to have hair to have long hair. Oh, sorry. Inadvertent.
It's you know, it's an absurdity.
So you concede these things. You concede, and then you'll contradict that. You'll say exactly the opposite 5 minutes later. It's absurd, but the most believable thing in the universe. No. It's absurd, and somebody should have wised up a long time ago.
And it's fine to mull around those ideas, and it's interesting to throw out such ideas. But that particular idea, I think, comes under heavy criticism very quickly. That doesn't seem to give them an avenue of escape.
Yes, it seems wrongly premised, and that can be pointed out. Again, I'm all for paying attention to even things that seem stupid. Like I said, this is particle gravity is a 300-year-old idea. And they just didn't even try to make it work. They didn't put in even that much effort to fix it. They just said, no, we don't even want to hear about combustion engines. No, 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 no. We got this Tesla thing. Infinite power. And they just said, let's waste all our money on our death ray instead of investing in the thing that works.
Except the only thing it has for it is its ludicrousy.
Look, these are all just relative comparisons. These theories, trying to find the truth, and yes, certain things can seem on their face stupid. God did it. But yes, you have to go through the evidence, and you find out, well, there's not just one avenue of destruction for that theory. There's so many avenues. God can't be irrational, yet he is. God can't be an asshole, yet he is. I mean, just simple stuff. Why would a god waste his time worrying about how long your beard is or, whether you're eating lobster? I mean, come on. What a waste of time.
On the ludicrousy of pausing all right. So in physics we have to, that's the inventiveness, that's the creativeness of physics, is to mull around what might at first be stupid ideas.
Yes, so now we agree. So there's no other choice. You have to really disprove the wrong theories. You can't just pretend they're wrong and just walk away. So yes, All of us have to try to make it work. And I've spent my whole life trying to make this stupid diagram of a photon make sense. I didn't just walk away and say, that's rubbish. No, I tried and tried and tried and tried and tried. It's rubbish.
So, for example, Lessage gravity. Lessage gravity, in standard reasoning, falls under the dogma, the criticism of drag and friction through moving through that kind of medium. Now, if somebody like Feynman, or it was Feynman's supervisor, what was his name, can say, why are all these electrons so perfect and identical? Maybe it's because there's only one. If he can mourn seriously, and then Feynman takes the idea of that and realises that one electron travelling forward and backward in time can then be every electron.
I don't even want to go near that. But obviously when Feynman starts talking about, well, look, in the future you shoot out an antiparticle and, but you will interact with it back here because the vector says you move faster than the speed of light. Okay, so he can say it, but everybody can know that's probably not right. that has some whoopsies in it, doesn't it?
And if they can mull around such crazy ideas, seriously, and get value out of them, then certainly there's value in saying, hang on a minute, what if, say gravity works perfectly as a gravity, it's got this question, what if it doesn't? What if it doesn't? What if it all works as we said, but we just say, for some other reason that we can't yet conceive or build in, it doesn't?
Well, it seemed like friction would have been something we wouldn't pay much attention to because we see it in the real world. We see the wrench that I throw in empty space and the wrench just goes forever. So obviously the friction doesn't exist. So the idea that we would assume friction to exist when we know it doesn't exist is kind of ironic, right? I mean, just in the sense that you would say, well, why don't we try to figure out why wrenches keep moving? And then we might be able to figure out why these little tiny particles wouldn't create drag. Because those two things probably are related.
Suffer drag through a medium. And that's kind of what Inmendham's done. Inmendham's, and he says, I don't fully understand it. Because the understanding of it, in fact, I don't think Inmendham has a proper explanation because it relies on an explanation of the structure. And on the one hand, he wants to...
Yeah, no, it just relies on the school of fish analogy. It just relies on the idea that the head-on collision has been made moot, irrelevant, can't possibly cause anything called friction. So all you're left with then is, the perpendicular. And the point is as the school of fish starts all moving the same way, there's no perpendicular fish to hit. You get it? So they all get pointy. So I could just say that fish can't hit each other head on, but they can hit each other in the side. So there, the game is over. So as I'm moving something, that means more of the fish are in the right pointing in this direction. There's less and less fish going this way, so I'm hitting less and less fish by exactly the same proportion. There's less fish to hit, exactly proportional to how fast I'm going. So I'm getting greasier as I go faster. So I can't possibly have drag anymore. More grease. I go 10 miles an hour faster, I'm greased 10 miles an hour faster grease. No problem.
Dismiss the being held accountable for, what the structure is of my past.
Again, I'm not dismissing the argument. Where am I dismissing it? I'm arguing these things you're arguing. I'm saying, look, from where this theory is now, if I spend all my time on this minutia, these people aren't even accepting evolution. You're saying the strategy is let's talk about complex genetics and the exchange of gene segments and dominance and recessive genes and do all that conversation when they haven't even accepted the general theory. You don't understand how that's not going to be a winning strategy for me, is to get bogged down in the minutia of the detail when I have to get them to accept the basic idea that, yes, human beings were, minkies.
And propose the theory of forces. But he can give intuitive possibilities of lines of inquiry and note that there are perhaps mechanical physical ways where it's not so unbelievable that, Lessage gravity and for some reason, it doesn't suffer drag. Therefore, he gets, and that's quite reasonable.
And it's not just some reason. I mean, I have given detail. I'm showing the little bits, and I'm giving analogies for how it gets thinner, so to speak, because more of its stuff is going the right way. I mean, I don't know. What the fuck? It's not a vague, well, the field did it. It's a pretty hard, analogistic, mechanical diagram I'm giving you of how something gets to be less capable of, or how something gets slicker as it moves faster. No friction. How it avoids friction. I've given a pretty hard, mechanical description of how you avoid friction. Just get thinner.
And I would posit, I mean, I've uploaded the videos, this is actually now current physics, because current physics is moving away from the notion of fabric of space-time and thinks of empty space as this quantum fluctuating medium. And this quantum medium has this mass.
Yes, that's right. And they're actually converting now solar masses into bent space, but they won't do it in any kind of honest way. And so what's the point? They're moving to the ether. But it's an ether. It's a dead ether, so it's not going to work anyway because it has no force capability in it. They'll never explain magnetism with a dead ether. That's not going to work. A dead, stagnant ether isn't going to make a magnet.
Property, essentially, it's clear to my eyes that it's going this way. They're going to reinvent, let's say, gravity in a quantum mechanical fashion, wherein quantum foam is the magical ether, and then you've got a strong correspondence really between in Menden's Lesage proposition and
well, again, let's point out it's not the Lesage proposition. I didn't even know Lesage existed, and the more important fact is that not only did I fix that, but it does the magnetism thing. It unifies the forces. That's the big one. Lesage didn't even think to extend it to magnetism because he didn't even, they didn't think of the polarization gimmick that makes it work. So, I mean, the big one was the unification theory. It was big doing gravity, but it was bigger unifying magnetism and gravity. With such a simple mechanism that also explains why electrons are electrons and why protons are protons. It explains why they function that way. Fuck. Now that explains why gravity works that way. Is because it's really weak magnetism.
Hammett, whatever his name is, who did the lectures, the end of space-time. There's a strong correlation in conclusions, in a sense, between them.
Yeah, I know, but you're saying the implication that, say, quantum mechanics and its idiotic notions that waves make force or waves make momentum is wrongly headed as unifying anything with either one of those two theories is a mistake, because both those theories don't understand force is force. Force isn't frequency. Momentum is not frequency. Frequency only matters when you have two things you're pushing against. As I'm pointing out, there has to be a ping pong ball, and they don't understand the ping pong ball. They're not understanding the quanta isn't in the effect, the quanta is in the cause. The quantum, the quanton. They still haven't gotten to the quanton, right? Isn't that what we're really talking about? They're missing the story until you realize it's all just quantons and electrons and protons and neutrons. That's physics.
One being really simple, and the other being, just unfathomably complicated. There isn't no.
Yeah. So yes. So the simple one is ludicrous, the bent space, and the unfathomably complicated one is useless because it's not really. It's got the wrong premise. It thinks a wave is a something.
Undergraduate courses, or even graduate courses in this. This is the total high-end, top physicist, brainiac mathematical physicists' conceptions.
Well, like I said, I'm watching some of the stupid Stanford ones, with what's his face, that guy. I don't have his name there. I don't know why I don't have his name on it. Damn, I just don't know why I can't remember names. Just seeing if there was another video in the related videos, but there isn't. But I mean, just insane rubbish. Every new particle they invented isn't really a particle. It's some abstraction of the force. And it's just so obvious. I mean, just like I said, they're basically calling, like I said, they're using math called an annihilation operator and a creation operator for simple interactions. So they're describing an interaction where I bump into something, and instead of saying I bumped into it, the force moved between us, blah 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 happened, he went this way and I went that way, they're basically saying we bump in, we annihilate, and then we get, we both annihilate, and then we get recreated in the new directions. I mean, it's just so not a true description of reality. It's using concepts that aren't even intended to be accurate. And to call it a particle when it's at the empty space left over, you get up out of your chair at the theater, and they're going to call the chair a you. There's a particle sitting in there. No.
And so Inventum is kind of ahead of those people, because he's looking to his quantum media to facilitate all the forces. And undoubtedly, we're philosophically hating the notions of action at a distance and so on.
Yeah, well, all that's gone. That's all this rubbish that physics is wasting all its time on. All these rubbish concepts are just going to go away now because they're done. This whole stupid, spooky action, entanglement crap was crap. And it's going. It's gone. It's unnecessary nonsense.
And, quantum mechanics still delivers a lot of spooky shit. You don't understand special relativity. And you called it general relativity. And
I really don't care. I mean, it's all the same. The word relativity is what's fucking idiotic. So it just doesn't matter which one you account it for. And whether it has to do with velocity or acceleration is another who cares. Because everything's accelerating all the time. You can't escape being in an accelerating frame, technically. So the very idea that any movement you have is permanent, or that your vector isn't getting changed all the fucking time, would be idiotic notion.
Nima Hamed points out, I wish I could remember his name, or something like Nima. Hamed Nima. It's a double-barreled. Anyhow, in a way, special relativity has turned out to be more fundamental than general relativity. These new ideas are all aimed at getting rid of the notion of space-time, but the one thing they can't get rid of is the notion of special relativity.
Anyway, I'll get to that later, I suppose. Maybe, possibly. I don't know if he's going to go into that or not. But I already made my point on it. I've already stated you can say I don't understand. No, I do understand. I'm saying you can't bend time. It's a silly notion. You can break a clock. That's it. There's nothing else. There's no warping of space or time. There's just your personal clock is broken. Period. It doesn't tell the same time. Period. But space doesn't bend. Time doesn't bend. That's all crap. And you can believe it if you want, but it's crap. And photons do one thing. No matter where I'm doing, no matter what I'm doing, they don't give a fuck. They start from the location you release them, and it's a location in space, and they move in a straight line to another location in space, in real space. And what you're doing doesn't make a goddamn bit of difference. You can't, as Einstein said, you can't give them more speed, you can't take speed away from them, therefore they're independent of these stupid relativistic frames, and you people, because they didn't say the sentence quite right, you think it means exactly the opposite, that the speed of light always looks like the speed of light. No, the truth is the speed of light always is the speed of light, and it doesn't care about what you're looking at. It doesn't care what you need to see because your mommy told you your teddy bear is in the future and you need to find a shortcut to it. Fuck that bullshit. The photon ain't doing it. It ain't going faster than the speed of light. It ain't going slower than the speed of light. You're fucked. You're not going forward. You're not going backward. There's no time anything. There's clocks that work and there's clocks that are broken. Period. The only clock that works is the photon. It's the only clock. It moves this far in this far amount of time. And it's always the same.